So hello and welcome back. So in this video we want to basically one of the fundamental things in trigonometry of course is angles, because all the time we are in trigonometry we are dealing with either angles or sides of a triangle. So we need to understand what angles are. And of course we need to know a little bit about triangles, and of course the sides of those triangles and the ratio between those sides in relation to those angles which constitute them. So the first thing that you need to know about angles is that an angle is basically a combination of two rays. And what I mean by a ray is a ray is just part of a line which has an endpoint, something like this. So this is basically a line. A line is something like this that extends in both directions indefinitely. But what a ray is just a part of that line that has an endpoint and then it extends in one direction. So it's something like this. So this is a ray. The endpoint, you can call it call it any letter, for example E, and then you specify any other point on that line or on that ray, and then for example this is ray, it is the ray EF. So this is ray EF, and you basically in symbol form you write it like this. So basically a ray consists of one endpoint, which is this endpoint over here, on a line. This, you remember that this was a part of a line, and all points extending in one direction from that point. So all points extending in one direction from that point. So the first point is called the endpoint of the ray. This is the first point, which is called the endpoint of the ray. And then we can refer to a specific ray by stating its endpoint and any other point on it. For example, I take this point E and then another point on the ray as F, and then I call it the ray EF, and in symbol notation I can write it like this. So this was basically a ray. Now an angle is the union of two rays. That means that if you have this ray over here, so if you have ray EF, and then if I have another ray, for example EB, for example, or EC, if I have another ray EC, for example, then if I unite these two rays, I will have a ray over here which is EF, and then I unite this the second ray with this ray on the endpoint. So on the basically on the endpoint you join them together, and then there is some rotation between the two rays. So this is still E, and then you have another letter here, for example C, and then this becomes an angle. So you can see that there is some rotation from the starting point, or let's call this the I don't remember the name of this ray over here. You can simply imagine that these two rays were overlapping, and then you keep this stationary, you keep this ray EF stationary, and then you keep rotating the ray EC in a counterclockwise direction just like this, and then you stop here, and then the angle becomes basically this angle over here, the angle FEC, something like that. So then angles can be named using a point on each ray and the vertex. And such, for example, this angle that we have formed over here, in symbol form you can write it as angle. This is the symbol of an angle, for example, CEF, and that is how you call and how you name an angle. Of course, there are also, it's very usually you can use also Greek letters that are often used as angle names, variables for the measure of an angle, variables for the measure of an angle. You need to pay attention to this. Of course, it's kind of ambiguous because some people use these as the name of the angle. Now here it's been stated that these variables are used for the measure of an angle, so we take this to be true. And so we have, for example, these Greek letters theta, phi, alpha, beta, and gamma, and so you can use these to name your angles. For example, this as you can see is the angle theta. I have no endpoints here, no vertex here, but just simply using this Greek letter theta, I can write this as angle theta. And of course, yeah, I was looking for these names over here, the initial side and terminal side of an angle. So what you need to do in order to form an angle, as we said before, you basically if you have an angle like this, of course this is supposed to be straight. So if you have an angle like this point where the two rays meet is called the vertex. This side is called the initial side. And this side is called the terminal side. And it's a dynamic process, meaning that these two rays were first just like this, overlapping. So this is the first ray. So that's, you can take this as the first ray, and the second ray is also exactly on the top of the first ray. So these two rays are essentially overlapping. And then you take the first ray stationary, and then you take the second ray and you keep rotating the ray in a counterclockwise direction until you reach your desired angle, and at that point you leave the terminal side of the angle, and that becomes your angle. And so then this becomes basically your angle. Now the angle that you form here, of course, if you want to use it, you need to be able to measure it. And the measure of an angle is the amount of rotation from the initial side to the terminal side. and the unit that we use for measuring these angles is degrees. So it's called degrees. And so what that means is that if you have your initial side of the angle over here, and then if you take the terminal side, now you can imagine that the terminal side is overlapping the initial side. You take the terminal side and you keep rotating it over and over again until you form a complete circle, and then you will get back to where you started, to the initial side of the angle. And the second ray is now overlapping the terminal side is now overlapping the initial side again, and then a full rotation around a full circle is called 360 degrees. So based on this, if I go one fourth of the way along this circle over here, 1/4 of the way, right, like this, it would be 360 degrees divided by 4, which is equal to 90 degrees. So this angle becomes 90 degrees. Then if you go 2/4 of the way, or half of the way, you will end up over here. Which is this angle over here. So this is 2/4 of the way, or half of the way, and that would be 360 degrees divided by, that would be half of the way, so divide by 2, so it's 180 degrees. So this angle is 180. If you go 3/4 of the way, you will end up here. So if you go 3/4 of the way, you will end up here. So this is 3/4 of the way around the circle. So that would be 360 degrees times 3 divided by 4, and this is equal to 270 degrees. So this is then 270 degrees. And 4/4 of the way, which is the whole way, or a full rotation, would be 360 degrees times 4 divided by 4. That is 4/4 of the way. So you can cancel these out, and you will end up with 360 degrees, which is essentially, you will get back where you started to 0, or 360 degrees. That means that here you have a 0-degree angle, here you have 90, 180, 270, and 360. And this is also 0 as well. So an angle basically in a standard position is just something like this. And so what you need to do is that you have a Cartesian coordinate system. You have a Cartesian coordinate system like this, and so the initial side of your angle is always at this position along the positive x-axis. So this becomes the initial side. Initial side of the angle. And then the terminal side of the angle, you move counterclockwise around this Cartesian coordinate system like this. You keep moving around this circle, and wherever your angle happens to be, that will be the terminal side. That will be the terminal side of your angle. And so then that is the measure of your angle, whatever that might be. So now if you have this angle, and if you measure it in a counterclockwise direction just like this, this will be that will be a positive angle by definition and by agreement. So for example, let's say this is 90 degrees, and let's say that this angle over here is 45 degrees, half of the way between these two lines. So then that would be 135 degrees all the way from here to here. 135 degrees. So 145 degrees is, I'm measuring this angle in a counterclockwise direction. Now there is one other possibility. I mean, by definition, I can start from the initial side and go in a clockwise direction, just like this. I can go in a clockwise direction until I reach that angle. And in this direction, I'm moving in a negative direction as opposed to the positive direction, which was the first case. So this is the negative direction. And in this case, so what do we have? We have a 90 degrees here, 90 degrees here, so it is 180 degrees, 180 plus 45 here. 180 plus 45, you have, so you have 5, 12, so this is 225 degrees. So this is negative 225 degrees. Because I'm measuring my angle in a clockwise direction, this becomes a negative 225 degrees. In a clockwise direction, I go, in a counterclockwise direction, I go this way. And so I will have an angle of 135 degrees, and it's a positive angle. So that's basically the whole story here about angles. So if you understand this much about angles, you will be able to use these angles very easily in trigonometry that we are going to have in the next videos here. For example, you can see that this is then the initial side and the terminal side, they are overlapping. So you are moving in this direction and you end up again here, and this becomes a 360 degrees. Or your initial side is here, you keep moving in this direction, you stop here, and then this is 1/4 of the way, which is 90 degrees, a right angle or a 90-degree angle. There is something else called quadrantal angles. You can see that here in this coordinate system that we use here to basically to draw our angles in a standard position. First of all, a standard position of an angle is where basically the initial side of your angle is drawn across the positive x-axis, and then you move in a counterclockwise direction, and somewhere along the way you draw the terminal side of the angle. So that is the standard position of an angle. So that means that basically the initial side of the angle is a completely horizontal line, and then so in this coordinate system, I have basically these two axes, and so when these two axes meet, you have 4 quadrants. So this is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Now if the terminal side of the angle lies on any axis, for example, if it lies here, you can see that now the initial side and terminal side of this angle 0 degrees is on the positive x direction axis. So now it's called a quadrantal angle. Again, your initial side is over here, the terminal side is over here, again on an axis. So again, it's called a quadrantal angle. Here again, a quadrantal angle lying on this axis, and here again a quadrantal angle on this axis. So basically the quadrantal angles that you could have are 0 degrees, 90 degrees, 180 degrees, 270 degrees. I suppose 360 degrees is also a quadrantal angle because it's the same thing as 0 degrees, which has been stated here as well. So an angle is a quadrantal angle if its terminal side lies on an axis including 0, 90, 180, 270 and 360 degrees. So that's basically different angles stated or defined formally so that we can use them in trigonometry. And so in the next video we will continue with these exercises, and then we have some conversion between degrees and radians, and so it's going to be very interesting. I mean, when you learn trigonometry, and when you it's just this whole story of trigonometry is about this simple circle, this unit circle, and these angles that you form around this circle. And when you understand this circle and basically the triangles that you can form inside this circle, then there is a lot of power at your disposal in mathematics. You can do almost anything with that. It's really powerful. So I'll see you in the next video. Thank you.